Another way that we can lift is something called a frontal lift. No, not that kind of frontal lift. Okay. When we talk about weather, we have a lot of fronts. You guys probably have heard this term before. Cold front, warm front. You guys heard those terms before? Okay. And a frontal lift, it's where basically, we'll go ahead and write that term down. Frontal lift. In that type of situation, the air is simply moved and raised because the two different air densities cannot mix. If you have cold air and warm air, which one's more dense?
Cold.
Cold is more dense. It's more compacted. Warm air is less dense. So when my warm air comes up behind cold air, it's not going to go through the cold air. It gets pushed upward over the warm air, or over the cold air. That makes sense? Okay, so that's how we get lifting. Now, when we have actually a cold front mixing with a warm front, that air is lifted super fast. And it's a very steep, the front of a cold front is a very steep ridge. It actually pushes that air up very quickly, which is why a lot of times when we have a cold front come through, that's how we start getting thunderstorms. So a lot of our major storm systems that come through are associated with cold fronts rather than with warm fronts. Two other ways that we get lift is convergence. In convergence, I have this warm air mass or this air mass, and when they come together, what happens? The air can't go down, you're at ground level, so what does it do? It gets pushed up. So that's convergence, so your air actually gets pushed up together via convergence of air systems. This is often the case with Florida. We're actually going to see a video of that here in a minute. And then the last one is convection. How many of you guys like thunderstorms?
I like sleeping.
You might want to start living east of a major city, not west. You're looking at me like you're a freak, but I'm serious. I mean, if you like thunderstorms, you need to live east of a major city. Like living right there at the Ohio border, directly due east of Fort Wayne, good place to find thunderstorms. You will not find them here. You'll find really good ones along I-80, just east of Chicago, but you won't find them here. It is a sense of convection. What is the difference between, all right, let's do it this way. Take 10 square miles of Fort Wayne and take 10 square miles of Garrett. What's the difference in the landscape? Oh, Austin?
Fort Wayne, there's a lot more buildings.
Buildings and cement. You ever walk on the sidewalk on a summer day without shoes? How's that feel? It's only slightly toasty. I mean, it's pretty bad when you start smelling your skin burning. But, that'll happen. That's because the cement absorbs a lot of that heat energy provided throughout the day. Well, then as evening comes around, guess what's happening with that heat energy? It's being released. So what is it doing to the air above it? It's heating it. And therefore all that hot air starts to do what? It starts to rise up into the atmosphere until it reaches the dew point, then we get clouds that form. So what happens in convection is you have this little hot spot. And it heats the air above it, and so your air starts to rise, and then it starts drifting off. So what you actually get is this series of large clouds that will form after the city. And then that's where your actual thunderstorms start coming down to the east of the city because of that. The problem here is if you go out due west of us, all you get run into is more farmland. Not a lot of heat sources coming out of the open land. That's why you get a lot of thunderstorms that pop up just east of the cities. Okay, so those are your 4 ways to do it. convection, convergence, frontal, and orographic. Okay? Those are your 4 ways to get air to be lifted up to start forming clouds. Make sense of that. So, any questions on how we get air to rise up? Let's take a look at some videos. No, not you. Ah, this is a good one. Now, take a look at the timestamp on here. Now, this is UTC, Universal Time Conversion Zone. But this is the time is actually going basically from 8 a.m. to 8 p.m. throughout the day. So we go fairly fast. We'll just watch the clouds that form. By the way, what's sitting right here? What major city?
I've never seen what it is. I don't know what.
You guys can't see it. It's over Florida.
Wait, so this is looking down at Florida?
Yeah, you see Florida right here?
Oh, okay, yeah.
What's sitting right there? Miami. Gee, isn't it odd? Isn't that a little odd that the major rise and the cloud isn't happening up here? It's not happening over here on top of the swamp. It's happening directly above Miami. What other cities sitting over here?
Where are you at?
Orlando?
Yeah.
Orlando's almost a little more up here, but Tampa, I think, is correct. So there we go. We got one major thunderstorm coming out, and there goes Tampa. So that's an example of convective lifting of warm air being lifted up and creating the clouds, creating the thunderstorms. That's why right now we don't actually have any frontal thunderstorms coming through. We did, what night was that? It must have been Monday night or Sunday night. We had that frontal lift that came through. That is an example of a thunderstorm. A lot of thunderstorms we're in at this time of year, though, are going to be convectional. I think they're called pop-ups. And that's because you get that heat that's released and actually creates these storms that just simply pop up. This one here is kind of neat. We talk about global wind patterns. Yeah, this one's much better. You can see how we get these global wind patterns that start to form. You can see how they kind of curl. So we're kind of going up in this random direction. But then if you look at the southern hemisphere, what do you notice about those winds? They're going the other direction.
That's like the whole world when all of it's used.
Yep. So you guys see, look at this. We actually can see that there's different layers to our wind patterns. You have a layer here at the poles that are actually going in this direction. You have the mid-latitudes going that direction, and you have the equatorial regions going in this direction. And then it's completely flipped again to the northern hemisphere. So actually these layers, these swirling wind patterns going around the world. Kind of cool. Oh, you guys might like some of those. We'll save those for later. So what I want you guys to do right now, we're going to take a small break, and I want you guys to work on a worksheet for about 15 minutes, and we'll come back and talk about the different types of clouds that we can get. So one thing that I probably should talk about very quickly is stability. All stability is the ability of air mass to resist lift. So stability is the ability of air mass to resist lifting. Why would an air mass not lift? Think about frontal lifting. Why would the one air mass not lift over another? You guys ever try to mix water and oil? Oil goes to the top. Why? It's less dense than the water. Because this is really important. I want you to think about this one. If the oil is less dense than the water, it flows up to the top. And so you actually go separate that.
Is it the same temperature?
There you go. What if their densities really weren't that much of a difference? What would happen between the water and the oil? They would just mix. I mean, you can still separate them because they have different densities, but it would just mix. If you have a warmer, again, that's the listen to the term, warmer and colder, yes, there's a colder and there's a warmer, but if it's not significantly different in the average temperatures, one will not lift above the other. They'll simply mix together. Right? So you have to have a strong difference between pressure, temperature, and all those other things. So we're going to go ahead and stop here, and we will come back.